We're going to be looking at our second exponent property day. To introduce us to this, here is a picture from the Harmon International Ice and Snow Festival. And here they have made a replica of the Great Wall of China out of ice and snow. And this person right here is a real person, and they're sledding down this replica. So it'll give you a little bit of a perspective of the actual size of the structure here. For today's exponent properties, we're starting out by writing the quotient without exponents. So for r to the fourth, it's going to be r times r times r times r. Then r to the first is just going to be r. Anytime you take something divided by itself, so if you take 37,983 divided by 37,983, or if you take 12 divided by 12, if you take centimeters divided by centimeters, if you take r divided by r, anytime you take anything divided by itself, it's always 1. So here, I've got r divided by r. Well, r divided by r equals 1. So when I do that, I'm left with 3 r's remaining. So to write this with a single exponent, you would write it as r to the, since I have 1, 2, 3 left over, r to the third. Now, again, just like yesterday, we need to come up with a rule where I could go from this business up here at the top directly to this answer without doing all this junk in the middle. So think about how the 4 and the 1 relate to the 3. Hopefully you figured out that any time you have a power divided by a power and you have the same base, all you need to do is subtract those exponents. So if you have a to the m over a to the n, that gives you a to the m minus n. Let's try that out. Here I've got 3 cubed times 3 to the 5th over 3 squared. I'm going to go ahead and simplify my numerator first. Here I have the same base, so I need to add them together. 3 plus 5 is 8. I'm going to keep my same base, so that's going to be 3 to the 8th over 3 squared. Now I could go ahead and write out 8 3's in the numerator and 2 3's in the denominator, but I've already figured out from my last rule that all I have to do is subtract these exponents since I have the same base. I'm going to keep my base of 3, then 8 minus 2 is 6. So that simplifies to 3 to the 6th power. With this one, my first step is going to be distributing this 3. So 3 times 3 is 9, so I'm going to have f to the 9th power. 3 times 4 is 12, so that's p to the 12th power. And I'm going to go ahead and bring over my denominator of fp squared. Now I need to simplify. Remember, anytime you don't have an exponent shown, your exponent is automatically 1. So I'm going to have, for my f's, 9 minus 1. So we'll end up with f to the 8th. For the p's, I've got 12 minus 2 for those exponents. Well, 12 minus 2 is 10, so that's f to the 8th, p to the 10th. Our last rule today, we're writing this quotient without exponents. So I've got this whole bit in parentheses raised to the 4th power, so I'm going to take it times itself 4 times. So I've got 5 over W, and let's see, I'm going to be lazy and group this together, copy, paste it. There's 5 over W times 5 over W times 5 over W times 5 over W. When you're multiplying fractions, you multiply the numerators together and you multiply the denominators together. So I can think of this as one giant fraction bar. Now to write this as a single power, I could just say, well, I've got 1, 2, 3, 4 5s in the numerator, so it's 5 to the 4th. And then I've got 1, 2, 3, 4 W's in the denominator, so that's W to the 4th. Again, we want to write a nice, easy rule for getting from the problem directly down here to the answer without going through all this business in the middle. So to complete this rule, if I've got if I've got a over b to the mth power, that m is just going to distribute. So that's a to the m over b to the m. So here, sorry, those parentheses are off-centered. I'm not going to mess with it. I've got p to the 9th over 5 squared, all raised to the 3rd power. So it's going to be p to the 9 times 3, or 27th, over 3 times 2 is 6, so that's 5 to the 6th. And that will be my final answer. Last one, example 4, and I've got some extra parentheses in here we don't need to worry about. Example 4, I've got r cubed p to the 5th over p squared, all raised to the 3rd power. So I'm going to distribute this 3. So that's 3 times 3, that's r to the 9th. Then 3 times 5, that's p to the 15th. And I'm going to put that over 2 times 3, that's p to the 6th. This is not going to be my final answer because I've got p's in the numerator and in the denominator. So I have to use that rule that we just started with during this lesson to simplify. My r to the 9th stays the way it is. P's in the numerator, p's in the denominator, I need to subtract. 15 minus 6 is going to leave me with p to the 9th. So r to the 9th, p to the 9th is my final answer. Your homework is on Canvas, and you are going to do numbers 21 through 36 multiples of 3. For multiples of 3, it's going to be every third problem. So it'll be 21, 24, 27, anything that if you divide it by 3, it comes out to be an integer. Good luck.